Now, Rachana, are you able to hear me?
Yes, yes.
Okay. Shall I start?
It's already live. You can start.
Okay. Hello, everyone. Welcome. Yeah, today's our discussion is on Databricks.
Here are three things you must know before moving to data science. One, data science is not all about coding. While coding is a part of it, data science has a lot more to do with
Yeah,
data.
today our discussion is on Databricks. We will talk about a storage concept called Delta Lake. Before that, I want to share you this information. We have these sessions happening. Let me close it. Yeah, we have these sessions happening. It is our participants who trained with us. They have got successfully placed in various organizations. You can go through them. You'll come to know their experiences, their interview experiences, job preparation experiences, so that you will understand what is the trend happening in the job market. And also, we are conducting these kind of webinars or sessions with industry experts. And you can see there is a playlist with various industry experts on the screen. You can just go watch them. You will understand how things are happening on the industries, how different people like data analysts, data scientists, data engineers, what kind of work they do, how they have to prepare to resolve those challenges. And let us go into our discussion, that is on Databricks. Databricks is a AI company. That means it's not just AI. Initially, when Databricks built, they have created a platform for PySpark. Since PySpark runs on distributed environment, Databricks is the company from where PySpark came. PySpark. It is a language or Spark rather than saying PySpark, Spark. Spark is a framework which can run on distributed systems. And PySpark is extension to the Python, which makes Python to use libraries that can work on distributed environment and framework like Spark. Initially, when Databricks started, it has created a platform for the people who can explore this PySpark. And then they have added many layers. Now, if you go and search for Databricks in Google, you will find that it has an AI company. Because not only just PySpark, they also offer various other layers, which we will discuss as we move on. And today we are going to focus on this part of Databricks called Delta Lake. Let us get into that discussion. First, we will look into various storage solutions we use for analytics these days. Data warehouses, data lakes, data lakehouses. Why we need these many storage solutions? Because today's data is big data. Data is available in various formats, different structures. If data coming is structured data, and that has to be used by analytical tools like BI tools to create reports, right? For structured data, we can choose data warehouse. Structured data after ETL, extract, transform, load, you place in data warehouse. From there, the analytical team, like business analysts, can create reports. Data scientists, they can used for the analytics, like building prediction models, forecasting models. Suppose what the data is not structured. Is there any storage solution? Before transform, if I want to save that data, is there any such kind of storage solution? Yes. For such kind of data, we have data lakes. What are these data lakes? They are scalable solutions, massive repositories. They can save unstructured data, structured data. In short, any kind of data you can put in there, structured, semi-structured, and unstructured. All kind of data you can save in the data lake. Example, S3 in AWS. In Google, you have GCS, Google Cloud Storage, and in Azure, we have blob storage solutions. And on open source, on top of Hadoop, you can build your data lake. We call HDFS, Hadoop Distributed Storage Solution, or Hadoop Distributed File System. Okay, we have separate storage solutions for data warehouses and data lakes. Now, if I want benefits of both, I want a centralized repository for my structured data, and also I want a scalable solution for my unstructured data. Or I am getting data from various sources in structured formats like CSV files, and in unstructured format like images, and semi-structured format like JSON. I want a platform where all of the data can fit in. I need this kind of data warehouse platform as well as data lake. And that's where data lake houses came into the picture. And Databricks is classic example of such a kind of platform, data lake house. And here you can put your raw data in data lake of it, structured, semi-structured, and unstructured. And also this Databricks provides you a platform to transform your data. Not only transform, extract, transform, and load data, ETL. It provides you the compute layer where you can do your ETL and also the machine learning part. They manage the clusters which are required for the compute. That is data lakehouse. Both. Directly you can bring any kind of data. You can do your ETL, or if you want to apply machine learning, EDA, any kind of transform on it. Compute layer is also available. And finally, once you transform your data, you can save them as tables. See, there is a data lake part and there is data warehouse part. Okay. It's not just the convenience only that led to data lake houses case. We have data warehouses, we have data lakes. There are certain missing things in the basic data lake, and that led to data lake houses. We will talk about them. Data lake. Just now we discussed. It's a massive repository. You can save any kind of data. It's scalable. As you put on data, it will accept it. It will support petabytes, terabytes of data. And it is good. Good for the cases like machine learning. But for the cases which involves analytics, where you don't require any kind of duplications, data lakes might not be the right fit. See, structured, semi-structured, unstructured, any kind of data you can put in your data lake. Data lake will not try to validate or organize your data into rows and columns without spending your time on transforming or organizing your data. Like you need not predefine your tables in data lake. You can just dump them into your data lake. From there, data engineers start their ETL pipeline, and machine learning, other people, if the data is of right quality, they can start off their data preparation validation, and feed it into their models. But with the basic data lake, there are some downsides. When to use this basic data lake? Today's data lake, which we find in clouds like AWS, Azure, and GCP, is very good. It can be easily integrated with many other layers, like a BI layer directly. But if you want to build data lake on open source, you will get a basic data lake. Even though that data lake is good, where you can just save any kind of data. That's it. But that data lakes are good because your data is coming in multiple formats. Some data comes in format of JSON, some data you extract from databases, some data you'll get from real-time streaming platforms. Then you need a platform. In such scenarios, data lake fits your requirements well. When you want to use this data in many different downstream tasks like analytics, data science, machine learning, the access will be faster rather than spending time to write schema of your tables and put data into the tables. If you just put data in the data lake, they can use more faster. Machine learning, data science. There is flexibility. You can run as many kinds of queries you want. Suppose if you put your data into some NoSQL database, you have to follow the language to query. If you put your data into any other kind of database, you have to use that particular query language. But data on data lake, you can choose language of your choice. You don't want to be locked into vendor-specific proprietary table formats. You don't want to just follow the structure, the query language of one particular vendor, then data lake is a right fit for you. But it has some downsides, especially coming to ACID transactions. ACID, atomicity, consistency, isolation, durability. They are very important in transactional database. Coming to analytical part, they are important in analytics too. In some scenarios, a strict ACID might not be a thing to be considered, but in some cases, yes, all these three are very, very important. Atomicity, consistency, isolation, durability, put together we call ACID. What is this? Atomicity. When you write or read from that particular data storage, atomicity ensures that each statement in the transaction to read, write, update, delete, whatever might be your operation, is treated as a single unit. Either the entire statement is executed or none of it is executed. So this property prevents data loss. Let us take an example. You as a data engineer has built an ETL pipeline for a business called some trend cart. It is a e-commerce kind of business. Now this trend cart people, the management wants reports on sales, returns, and user behavior. For that, you have to extract the data. First, you bring into the data lake. From there, you will transform the data. And after transformation, you load into data warehouses. From there, the BI department can get data. Or here in the data lake itself, you are transforming and saving the data directly. From there, even the BI developers are getting the data. Let us consider this part. ETL on data lake. You'll bring in data, raw data to the data lake, right, on a schedule basis. From there, you'll do some transformations like data validation and all, and you'll save it back to the data lake. So curated data is also available in the data lake. From there, BI developers, they'll try to access the data directly from the data lake. Sorry, let us not put data warehouse here. They'll try to query, get data, and build reports. Let us say we have designed an ETL pipeline that runs every day on some 1 a.m. The day all that day happened, the sales transactions will be extracted at 1 a.m. On one particular day, what happened? At 1 a.m., the ETL pipeline started. Extracting data is happening into the sales table. So already the data is there in database. From there, we are extracting the data into the sales table, where in our data lake. Some network error happened. Let us say this particular database for that day has some 1 lakh rows. Changed rows, inserted rows, updated rows, altogether some 1 lakh rows are there. Some 70,000 rows we extracted successfully. Somewhere around about to complete, there is a network issue. The extraction stopped. Now BI developers, they are trying to read this table, which is in data is in data lake. On top of that, there are tools and techniques which gets your data as tables. BI developers are trying to query the table, broken table. What they get? They might get misinterpreted data. Say for a few rows, price has not been updated. They'll get all the missing price values. They cannot take this to the reports. Right? Why? What happened here is the data lake is not having atomicity standards. It's not following it. If there is a strong atomicity, the extraction either will happen fully or it will stop. It will neither happen at all. If it happens, it will happen fully. That is atomicity. And the same way, consistency ensures that transactions only make changes to tables in predefined, predictable ways. For example, quantity table. In orders, when you are extracting the orders from the database to your data lake should have a rule which should check that no quantity should be less than 0. So when people ordering, they cannot place orders less than 0. If there is any kind of such invalid entries for some reason, your data lake should be able to stop it. That is consistency. Based on the business rules, it should not accept the data. Like quantity should be greater than 0, unit price should be greater than 0. If payment status, either it has to be a success, failed, or pending. We should not expect any other numbers on payment status. Only these 3. Such kind of predictable ways, predefined rules will be applied on your data. And read operation, write operation, or any other kind of DML operations, that is consistency. Isolation. Each transaction should be isolated. Let us say transaction A is writing data into the data lake. Transaction B, the same data set or the table in the data lake. Transaction B is trying to read that data, that is B. Both are happening simultaneously, but they should be considered as isolated transactions. Otherwise, what happens? In the midway, when transaction A is happening, it is inserting some information. Same time, transaction B is trying to read it. It will get broken data, missing data. Half of the values in the row, transaction B will get it, other will be missing. So the things has to be isolated. Only after transaction A is done, the row should be available for other transactions. There should be isolation. Durability. The storage system should maintain durability of the data, ensures that changes to your data made or successfully executed. You have updated some stock on the data in your data lake. Some issue happened, network issue or some other issue happened. You thought it got updated, but it is not actually not because you don't get acknowledgement. Your data lake is not following ACID transactions. It will not get updated in the data lake. Eventually, the BI developers, what they get, they'll get old data only. They'll not get updated data. These are the issues with data lake. Data lakes are good for historical data. Suppose historical data is already available and the changes will not happen to that, like update, delete, insert. Then for such kind of data lakes are good because today we have big data, massive amounts of data should be handled. Massive volumes of structured and unstructured data. We need a storage solution which helps to access the data more faster. But when you are doing analytics on the data, that has a nature of changing. Changes might happen. Daily changes, hourly changes, monthly changes. And that's where data lake is failing, especially the data lakes that you build on Hadoop framework or HDFS lack these ACID transactions. And that is why clouds came into the picture. One such cloud is Databricks. But before going to the Databricks, we have to talk about Delta Lake. And after these data warehouses and then data lakes came, there are issues with data lakes, especially. To resolve that, Delta Lake is an open source storage framework. It came into the market. It is open source. A lot of people are struggling to adopt it. So clouds like Databricks adopted it and they provided a platform where you can make use of that Delta Lake. This Delta Lake is Lakehouse, data Lakehouse. That means you can bring in your raw data as it is here. And also you can write your data into tables as you do in data warehouse. And the important thing here is ACID transactions. It ensures that atomicity, consistency, isolation, durability, everything is there. Suppose the same scenario happens in Delta Lake. Extraction is happening at 1 a.m. It will take around 5 minutes, let's say. Somewhere around 1-4. Some network issue, extraction didn't happen well. That means that extraction is failed. That particular transaction is failed in Delta Lake. It's not like Data Lake. If a BI developer tries to read data from Delta Lake at 1-5 a.m., he or she will not get it. They'll get old data only. They'll not get new data. Then how it gets that transaction happen is using rollbacks. Again, it will start over at 1-5 a.m. This time it will get it correct at 1-10 a.m. The ETL extraction successfully has completed. We will get tables or files in Delta Lake. And at 111, if anyone tries to read, they'll get the total updated data. They'll not get the broken table or broken file. So earlier, it was not there in Data Lake. Now Delta Lake, it follows atomicity. Not only atomicity, consistency. You can mention the business rules. You can validate the data before coming into the Delta Lake, whether it's satisfying the business rules, relations, and any keys you mentioned that should be there. For example, some data is coming, in that data region ID should be there. Entries to that table cannot be made without the region ID. Such kind of rules you can put it for. It has the consistency. It allows you to follow some rules in your transactions. Isolation, when simultaneous read-write operations are happening, any kind of operation, update, delete, are simultaneously happening, it ensures that they happen in isolation. And durability. Delta Lake ensures all of these assets happen because it saves your data. It saves your tables in versions. Version 0, version 1, version 2, like that. So always there is a good chance of durability because of this versioning. That is Delta Lake, guys. And also this Delta Lake follows this kind of architecture called medallion architecture. When data comes in its raw format, they'll go to bronze. In bronze table, it's like data lake only. It is messy. All kind of data you put there. And then you refine your data, cleaning the data, you'll save it as a refined table. And you apply some business rules. You'll validate data by applying some business rules, checking, as we discussed, quantity should be greater than 0. Otherwise, you have to drop that. It is some invalid entry that happened. And then finally, you'll get gold store. In this way, Delta Lake ensures all the data is according to ACID transactions. And data lakehouse architecture according to Databricks, all data sources, any kind of data can come into Databricks. Unity catalog is there, Metastore is there. Unity catalog, it accepts data in both raw format and tables. That's why it is called as Unity catalog. Your raw data as well as the table both resides in the same platform. It is a data lake house. And also in Databricks, it has adapted this Delta Lake. As soon as the data sources send data, they'll be put into the object storage. And from this object storage, they call it as data lake only. Data lake or just Unity catalog. And Databricks. Data will be as it is. And from there, you have to convert your data into Delta table. When you convert your data into Delta table, it arranges your data into rows and columns. What is unique here is creating versions for that table. And also it adds one more column called transaction logs. These column or this attribute transaction logs helps the Delta Lake to track, especially making that isolation happen when simultaneous requests, read-write requests are happening. It ensures that read is a different thing, write is a different thing. It will not allow to break in. those two queries will be isolated. To all this, Delta Lake should have a track of what is happening, and that is transaction logs. Based on these transaction logs, so what transaction happened earlier, what are the transaction happened past hour, all the logs will be saved. And that makes the data lake as Delta Lake, versioning and saving the transaction logs. And data lakehouse, there will be a meta store where all the metadata will be saved, and you can write the data into tables, transform them, again write the transform data into the delta table, and you can curate it more, like bronze. This is bronze layer, this is silver layer, where you have cleaned data, and again you transform it by applying business rules. You will get gold layer. From there, your feature stores, apps, BI tools, all of these analytical tools or applications can make use of data. And through this kind of architecture, having both data lake and data warehouse on the same platform will make ETL way more easier and faster. And that's why people are adapting data lake houses more, because you'll be having everything on one single place. Raw data, curated data, everything. ETL will be way more faster. Okay, that is data lakehouse. Now coming to the Databricks. Databricks, when it started, it is just a PySpark platform. Now, Databricks has layers. They have compute layer, they have storage layer, they have all these. Okay, just give me a minute. Okay. Users, applications, if you want to make use of Databricks, you have to create one. What you will get in your Databricks account is control panel. In control panel, it's like a central management of Databricks where users can interact. You have your web application, compute orchestration, like you can create notebooks to write code. You can create tables, databases. If you want a Unity catalog, if you want to upload a file into a Unity catalog, if you want to read data from the Unity catalog, if you want to query the code, you can create SQL notebook, PySpark notebooks, you can run the Python code. This is like a user interface, that is control panel. As soon as you log into your Databricks, a bunch of options will be there available for you. That is control panel. And then they also have the compute plane. It's not just a storage Databricks is offering. It's not just the Delta Lake there is offering for you. A cluster of compute power, a cluster of servers beneath your Databricks account will allow you to process the data that you bring into the Delta Lake, which in Databricks is called as Unity Catalog, which is you can call Data Lakehouse or Delta Tables, or just Delta Lake. Right? Beneath this, you have servers which can allow you to process this data, get this data, transform this data, process this data. serverless compute plane is there, and zero management from your part, zero maintenance from your part. Of course, this is your cloud account. And the data lakehouse architecture that is well managed by the Databricks. That is about the Databricks architecture and high level compute, control, and the resources they manage for data lakehouse. They'll manage the Delta Lake tables and the data lake part. And also they offer you the compute where you can interact, query, write code, and process these tables. And on this compute layer, you can also perform machine learning and AI and data engineering. Like ETL, you can interact with your data and build machine learning AI. It supports, it's a one-stop. That's why it's being called as AI company now. Right. That's it, guys. Hope you have understood about the Delta Lake and the Databricks. In next session, we will see how we can do the transactions on Delta Lake on Databricks.